let me introduce Jarek for you. He is a Fluor Fellow, Subject Matter Expert SME, Discipline Application Specialist DAS, and Innovation Catalyst. He has over 25 years of experience in energy and urban solutions. He is focused on BIM and plant software, data-centric execution, digital twin and building information modeling, integrated project delivery, and lean construction. He is an ambassador of Fluor's Professional Publications and Presentations Program, P4. He was named P4 Author of the Year 2020 and P4 Rookie Author of the Year 2018. Thank you.
Good afternoon. This is a great honor to me to speak today among people who share knowledge and expertise with openness to digital innovation. Today, the railway is in the spotlight, but I make some assumption. If Richard Beeching had known the digital twin in 1960s, he would never randomly started to make the Beeching cuts on railway. Critical infrastructure requires reliable information and responsible decision-making based on data. This is why I will focus on well-managed information in this presentation. What I will be sharing is majority my thinking connected with 15 years serving in Fluor and also understanding the impact of global infrastructure and the global projects, which makes a lot of nice tricks, but also some challenges which are not obvious. But at first, where we started indeed, it will be Euclid. What we are doing now, we have additional plenty of layers, but indeed without his plane geometry and axioms, we cannot be here. We remember that just yesterday we used these tools. Today we are using more computers, but can we imagine that the next part of projects in 10 years it will be only tables with data without any graphical information? Organization of information is one of the key aspects which we need to understand. Everything is starting from the chaos, but just where is the magic button? The magic button can serve us and can serve others. Also, just for me, as when I came from Poland, what is the kind of smart information, the metadata? For you, it's obvious. For me, without this, I will do not survive first crossing. The same, the famous mind the gap in underground is give me some comfort that I know that the gap exists not only in Poland. But when you look about reliable information sources, we live in ChatGPT era, which makes for me some understanding that we can make more or we can make less. What we can make more, we can understand the question which I had to do with ChatGPT. It was whether an engineer is an artist or rather a craftsman. I did it a couple of times and always I found something which makes me happy. But when we compare now to the Google, which is outdated, we can say, with Google we know the sources. We can check if we trust these sources. With ChatGPT, our assumption is this is true. However, you can imagine, it's like a Twitter. What is the most popular will be aggregated by ChatGPT. If something will be wrong, our input will be also wrong. What is big data? Big data is one of these words which we love, which we hear, but it's really challenging. We started from megabytes, gigabytes, terabytes, but due to the IDC Global Data Sphere, in 2020, almost 65 zettabytes of data was created or replicated. The amount of digital data created over the next 5 years will be greater than twice the amount of data created since the advent of digital storage. But with zettabytes, yottabytes, which are just theoretical at the moment, is coming to the first. And what with this black hole, which we know from the stars? We go to the place where we cannot control the amount of data if we do not find where is the noise of data. That when we go to the big data, there are 7 V's. The first is volume, which determines the size of the data set. But it is difficult to define a limit valve because the amount of stored data increases with passage of time. Yesterday we used terabytes, today zettabytes or even yottabytes. It can be said that the limit is the possibility of using traditional computational and statistical methods. When the data sets do not meet this condition, it is called big data. The second is variety. It describes one of the biggest challenges of the big data. It can be structured, unstructured, or partially structured, and it can include plenty of different types of data, which was earlier mentioned, from the text documents, spreadsheets, through social media, posts to XML, and other data formats. There is a significant task to organize the data which could be changed rapidly in format. Another is velocity. A large volume of data is streamed continually from sensors, smartphones, and autonomous robotics, IoT, Internet of Things. The speed of processing data is related to their volume. Faster data generation increases their volume. It is important that critical data is processed without delay. For example, an autonomous vehicle data. If it will be delayed, we know what's happened. Veracity refers to the assurance of data quality and processes which filter and remove the bad data from accumulating in system. This goes back to data standardization and engineering data quality management. Visualization. Visualization provides an interactive way of presentation of vast complex data in simple and understandable form, providing information about trends, for example, analytical stock, market charts. We know that yesterday we used Excel, now everyone using Power BI, but indeed it's just the difference of providing our data. Value. The usefulness of data for business is ensured by the analysis in which collected data are extracted to provide useful insights. Then data with merit can add value to decision-making processes. And the last one, which is also very important, is virality. It describes the time needed to spread word of mouth data among people. For example, Twitter tweet in global range. 2 factors are important, time and rate of spread. The system story, which I really like, is very helpful in big data analysis. Replicated, reinforced, widespread by big data analysis can contain errors in data provided by people or Internet of Things. We just trust that it's going everything okay, but we know that something happens. Stereotypes included in algorithms. It's more and more is done by IT people, not engineers or not specialists, because the high sophisticated software requires a really high level of knowledge. Pre-filtered generalizations. That could cause some root issues with the data which we're using. And that what we can do, it's according to this theory of systems, changing one component of the system affects other components of the entire system. This is a case where alliances tried to understand what was the most damaged part of the airplane. And for the people who tried to understand it, it was where is the hole. But here is coming the Hungarian statistic, Abraham Ward, who said, no, we need to use the places which we cannot see because this aircraft didn't back to the airfield. That it was just, very small change, but completely derailed the previous understanding of the data which flow through the time. This is the place when we need to have quality assurance. And according to ISO 8000, it should be implemented in 4 major parts, which is plan, connected with data quality planning. We do that we have real quality control of data. We need to check the quality of assurance, as well as the last, we need to make constant improvement, quality improvement. You can imagine that with small set of data, we have some processes which works. With large set of data, we need to build new processes. And also we need to have resources. It could be first trained resources, but it also need to be data-related resources like IT. Let's look for level of information need. Can you imagine that color doesn't make difference? It's not factor which is used. I use this bricks just to show that sometimes we believe that factor which we use or property which we use is really important. Maybe it's important for us, but not in the context. Here, the shape and where should be plugged is the most important. That indeed we need to start, I think, in each company, in each environment which we work, to think which data are required. How can this data can be managed and used effectively in our context, in sharing or interoperability? Which are the real engineering authoring tools? We use a lot of tools which are not talk each other, but maybe it's the time to develop something new, just a general idea. How can engineers achieve consistent data? That is another challenge for engineers of today. Data modification. It's really easy to modify the data. However, from my experience, we're struggling that we don't know quite often who, what did. That we need to know a special signature, digital signature, who did it, what he changed, when he did it, because then we can understand if it's the data workflow or documents which require this, where it was done, and why. And of course, how. This is really important, the first step to really navigate with big data. It's a lot of developers which provides many different solutions, and when we go to the digital twin, it's something which needs to be on the radar from the very first day. When we go to the metadata schema, there is a lot of options which we want to use. That currently the highest level is semantic, but it could be many different types of classification. We need to develop glossary, tags, data dictionary, and databases and attributes, which are rely on the business lines or countries or just something which is the most important in our local context. Schema and analysis. Data today is used in a new way. First, we can serve with multi-classification, more like in biology, including taxonomy, that we can combine data from completely different levels, which previously in engineering it was treated, oh, we cannot do it. Relational references, that we need to find what is relation between certain data. This is semantic, as I told. The ChatGPT is so charmed because it's just semantic. We cannot say that it's just written. We believe that someone is typing for us this answer. Real-time processing of data for IoT, for Internet of Things, as well as using artificial intelligence, which is enhancing big data analysis. Let's look for a second for digital transformation. We use it, I think, with digital context. It's the best illustration when we have a digital model where we have physical digital object updated indeed manually in both way, or where we are going with a digital shadow when automatically is transfer data from physical object to digital object. And something where we are going and we want to be the digital twin. Maybe in a few years we will have another new fantastic word, but the digital twin is for us at the moment go that we want to get full automation. We are still on this way. During the previous presentation, I noticed we talk about data standards. It's something what we're struggling as well in company. That data standards were developed to enable the data transfer between all parties. And for example, in oil and gas, what was done by Shell is CFOS, which is called Capital Facilities Information Handover Specification. It's also developed currently DEXP, which is data exchange in the process industry. It's also this ISO 19526, which is industrial automation system and integration. And also maybe the most famous but not most liked, .ifc, the industry foundations classes. But it makes a lot of situation when we think that we can transfer the data, but indeed it's not going in that way. It's another problem on global scale. The large number of construction classification. Just in the US is for omni-class uniformat master formats and some additional. In the UK we have uniclass. There are in Nordic countries co-class, about 20, 25 formats, and they still propose new formats in new countries. Also, level of development or level of information need, which we need to think in any digital object is required. We have American standard, which is the level of development by our AIA, Architects of America, which is used, but most people, when I ask them, do you understand what is here? They say, oh, it's 100 or 200, but they really do not understand that it's not only graphic, it's also information. Or we have the levels from 1 to 7. And a lot of countries adding now this semi or semi categories. Also, ISO 19650 connected with BIM, it's not making it easier. I think it's making it more academic, that it's far away from daily routine which we want to serve. And the latest project, which is still undergoing the level of information need, the new ISO, I think it will be really complicated that for the people who want to do it easy, it will be not easy. With digital twin, we will have this option to get really good information about urban area. First, we can use geographic information system. We can use laser imaging detection and ranging. Also, we have ICAF maps in many of cities with a long history that we can understand when it was the specific flood, what was the impact, which areas were. For example, in my country, in this area, quite often they build new buildings, which is just against the understanding why the historical data are so important. And also population statistics, which give us understanding where will be the vibrant area of the city or country and how we develop. All these layers are very important. Now, when I think about digital twin infrastructure, I think that historical data represent the past, while real-time data present and simulate the predicted future. It's also help us in development planning. And with these models or shadow or digital twin, we can avoid clashes. We can avoid interferences between different participants in the projects, or if we have on the government level, we can use the best data to avoid delay and obstacles when someone crash the pipe, which is the most important, or the, we can say, national phone lines, landlines, which are serving to everyone as critical. Because we know when we have mobile, we need to have the second option, what's happened when we have no power. Simulation with AI. It's really impressive what we can get in AI, but we need to understand that it's algorithms. It's not someone with double brain. It's just what we request from this tool, it will be providing us. But on construction side, we can predict size, location, and impact on environment. We can prepare several variants. We can ask for several variants of the schedule and the size of the crew. You can imagine for planners, it was a long of time to prepare it. It took months or weeks. Now AI can make all these algorithms in one day, sometimes even shorter. It also can be used to quickly update it. Modularization or stick builds. With large-scale projects like in America, quite often it's better to make it in certain place and transport because the labor rate is so high. In Europe, we don't have so often this situation, but also we have rivers. We can make it in some places where we have really good welders and transport it just to the site. We don't need to make it on site. And also something which for me is critical, the advanced work packaging. We need to think also about digital twin, how we can combine some information to special packets, which help us to make in many different areas the similar scope of work without reinvent the wheel, without doing again the same engineering. Another issue which is coming with the new methodology of digital twin and all these industries, scale up. With Industry 4.0, we, especially pharmaceutical, we can have a really fantastic model of data how to produce some diabetics or biotechnical drugs. However, the problem is going when we go from the laboratory scale to the large scale. That is another challenge which we need to use. Also, it could be in context of construction, how to quickly enlarge the model which we have for the small site to the large site. The simulation which we can do quickly. Single physical object to a city or even to a country or continent. But this using of one object, we can leverage to the plenty places. Reduce time and impact on environment, that it will be business map of processes or large scale models. Also predictions. What if scenarios in this one of previous presentations, it was what if start to be what is. But I think it's what we need to understand. We have based on historical data and current status, we can check if it's going in the proper way or not. Ongoing monitoring of processes, that it could be analyzing the impact on subsequent processes delay acceleration. Since 2018, Fluor uses IBM Watson. It was developed something which is EPC, engineering, procurement, construction, project health diagnostics, how it works in general. Is grab the data from engineering, from other parties, and it makes the information which other future process can be delayed. That before we go to that point, we know that it could be delayed and we can change the scenario. Dashboards and reports. Power BI and similar tools enable filtering and analysis appropriate to the management level. Data visualization, not only a virtual model or render, is more and more often the visualization of data statuses from the database. Monitoring, of course, Internet of Things. Monitoring physical object and immediately update status in digital object. It is our goal with digital twin, what we want to achieve. Provide back correction to the physical object, that we know that something is going on site or in building or in airport, and we can immediately protect this. Critical infrastructure, that how we can use it. This Isle of Wight, it will be, for example, fire, flood, disaster, terrorist attacks, or war. it's more or less is what's going now in battle in Ukraine, where the brainiest Ukrainian people use indeed this critical infrastructure, the knowledge to predict and protect with fighting with a stronger country. Also, intelligent transport system, which can serve us in many aspects from current situation. But there are also risks. More operation can be performed, but why optimize the information? We are lazy. When we have better computer, we do not serve better data. New version of software, digital twin or whatever, new schema specification and relational tables. We need to upgrade it. We avoid upgrades. Search algorithms are based on pre-filter information. Filter keywords can eliminate important information before it reaches the addressee. The cost of data storage, limiting of updates and monitoring inputs, and of course IT security. With this discussion, which was previously, I noted two very important things which we're thinking about now, but it's internal set of data. For example, engineering provides in company to estimating, procurement and supply chain. And it must be developed in company because this is the context of company. But also it will be external data, like what should be shared. And this must have a layer where we think that security is proper. And on the global level or government level data, digital twin, data mapping, unified format out and in, that our internal data, when we start to push out, it's going with the same format that we can communicate. In my understanding, digital twin in a life cycle is going indeed before the engineering, because what is operation and maintenance is like circle. Operation and maintenance need to provide the proper question, the proper data which they want to achieve before we start engineering, just in concept, because everything must be written down, and we need to start from that position. If we start at construction, operation, maintenance, no one from engineering will provide it. Maybe we need to have double resources to create in construction phase engineering. But it's really important, all parties, when we divide it from CapEx and OpEx, with the digital twin, we need to understand this is everyone, CapEx and OpEx must be involved, and they need to treat that it's not save cost if we make less in engineering construction, because never they will have this information. The best example is Berlin Airport, when they have delayed 7 years because they wanted to save some money. And I think one railway in London as well. That summarizes it. Well-managed information is the key to the future, and digital twin, and I wish everyone from us that we go in this direction. Thank you so much for your attention. It is a great pleasure to be there. Thank you.